Special place, which is the Centre for Cancer Research connected to Queen's University in Belfast, and it's actually near the City Hospital. And I have got Colin here today, and Colin has been showing me around the lab already and explaining. We've had great conversations. I've also got with me two very special people. This is Rachel, and Rachel is the person I got in contact with at the start of all this when, if you remember, I wanted to do my Just Giving site. So, hello there.
Hi.
And Rachel does a lot of work with charity, and with the charity specifically connected with this lab. So we're just going to do a wee tour around. We've been looking actually at, I'm going to show you this. I'll turn my camera if I can. We've been looking at plates this morning and trying to... I'm listening to what's going on here, but I never was a scientist. Colin is the one who knows all about it. Colin, tell us what you are actually researching at the minute.
Hi, so I'm looking at women who've had 2 breast cancers. So after you've had 1 breast cancer, there is the potential to develop a 2nd breast cancer, but at present we don't know who's at a higher risk than anybody else, and that's essentially what my research is looking at. So looking at things at a genetic and molecular level within these patients.
So isn't that really, really interesting? Regarding myself, I find this really interesting because of what I've been through myself. So that's one of the sort of research campaigns that's going on here at the minute. Of course, there's probably thousands more, isn't there, as well? I would say the whole breast cancer thing is ongoing the whole way through, and we're going to just go along and see exactly what happens in the lab. So just come with us. Is step 2, everybody, and this is Maggie. And Maggie's going to talk to you a little bit about what she actually does in the lab here for Queen's University. Okay.
Hi, so I'm a postdoc in Keenan Savage's group. I was saying earlier on that I do a bit more of what we call the basic research. Okay, so there's a lot of cell line work and a lot of just looking back at what is going on inside the cancer cell. In particular, our group is focused a lot in BRCA1.
Okay, can I ask? So this would be when people has a sample taken from them, then it comes here. Would that be right?
Not so much with us.
Okay.
That would be sort of Colin's speciality, I suppose. They are the ones that have the access to patient samples.
Okay, all right.
What I do is we work with immortalized cell lines that we have.
Right, okay.
And we're sort of looking for general processes that would happen in any of our patients, and particularly for me, because of the group that I work in,
right.
BRCA1 mutated patients.
All right, that's really interesting because I know that's very topical, isn't it?
Yeah,
now?
Absolutely, yeah. So in particular as well in our group, we're very interested in the DNA damage response, okay, that has been going on inside the cell, and how the cell having a BRCA1 mutation, how that impacts the DNA damage response,
right.
Okay, and how obviously then we can exploit that, be it for therapy, prevention, you know,
right.
what to do about that.
Important jobs here.
Okay, if you're interested, I'll actually show you a bit of the cell lines that we have growing at the moment.
I would like to see
I
this.
also
Let's see.
think it's interesting to be able to see something under the microscope.
Oh,
okay?
wow.
So I don't know if Colin had the chance to show you the clonogenic assays outside.
Not yet.
I can show you
We'll see
then.
that. We'll see that.
This is the setup stage, and then I'll actually show you the end result, okay? So this is just an incubator. It pretty much functions like a human body, okay? So we have our temperature set at 37 degrees.
Nice.
We have our CO2 controlled, okay? So can't keep it open too long, I don't want to upset them. These were split today, so they might not actually be the best thing to look at. I'll show you something that I know is...
Okay, so this is really interesting. I'm out of my depth here in a lab. Bring me the harp, bring it to me. Anyway, very interesting.
Like I said, we're sort of looking at all the pathways and things going in inside the cell, so a bit more.
Okay. So this is a culture that's been growing.
It's a culture of cells that have been growing for a very, very long time. Okay, and I'll show you. I don't think you can get it on camera, sadly, but
we'll not be able to let you guys on here see this, but I'm going to have a little look myself.
Okay, but I'll let you guys
So how do we look down the microscope there, and that I had a look at the cancer cells and that are growing in this culture. I just can't believe that just these marvelous people can do this. It's absolutely brilliant. Okay,
we can grow them indefinitely, okay? They're pretty much what we would use then to start from here and then do all the experiments and look at what is going on, what's deregulated mostly inside.
So on these samples then you would try various treatments for healing?
Absolutely. So for example, the plates that you filmed earlier on in this incubator, the 6 well plates, and I can show you outside what they look like after. What would happen would be I would grab one of these flasks, I would plate these cells at different densities, okay, and then apply different treatments to them, be it radiation or any DNA damaging agents, chemotherapy, and then we'll look at what impact that has on cell survival. Okay, and then I'll tell you outside, I'll show you the plates, how we actually calculate that. So we know that we seeded a particular number of colonies. At the end of it, after about 7 days, we'll stain them and then we'll count the colonies to see how many of them survive.
Can I ask then, when you're actually doing this, is this an exciting job for you to see when some treatments actually work?
Oh, absolutely. I think you can't work in this without being excited about it.
Do you go home? Do you go home at the weekend and think, I can't wait till Monday till I see what's happened in the dish?
Sometimes we're here at the weekends. It's not a particular 9 to 5
but
job for us.
in all seriousness, isn't it fabulous what they do? So this is where they actually take these cells and test them and see which treatments worked. We'll be back in a little minute. Okay, we are back, and now Maggie's going to tell us what's happening next.
Okay, so I'm just going to show you now what the end result was of the 6 well plates that I was saying that we plated earlier on. We'd have left from approximately 7 to 14 days to let the drugs do their job. And now the end result looks something like this, okay? So, like I said, we would have plated different amounts or different numbers of cells, okay, into these in duplicate, okay? And then what we're doing here is this one in particular is just a normal cell line, a kidney cell line, okay, kidney cancer cell line that has been treated with chemotherapy, okay? And
so which is the chemo one?
This one is actually a PARP inhibitor, okay?
Okay, all right.
So we're hoping that obviously they're going to be sensitive to the treatment, okay? And the way we sort of look at those things is sort of if you can see from this plate to this plate, obviously this had a higher treatment. Obviously you see a lot less colonies, okay? The colonies are just...
more chemo then.
More chemo, obviously, more cell death, okay? And this is how we sort of test. This is a cell survival assay, okay? So where we're evaluating the cell survival after a specific treatment.
You do the same thing with radio?
Absolutely, yeah.
What other sort of things will you do?
So you have X-ray in the building, so radiation and a lot of different chemotherapies, okay? Different agents.
And are you able to put other medications?
Absolutely, where we could try different combinations of therapies.
So isn't that really interesting? This is where all the research is done for the medication for breast cancer, etc., is carried out. So I think that's really interesting.
Yes. So again, like we're saying inside as well, all of these experiments are then done in triplicate at least to obviously make sure that the combinations we're getting are right, and that they're obviously showing us that there is or there isn't sensitivity. In some cases we can actually just see that a particular cell line is resistant, and then we could be chasing that.
So what sort of a thing would be resistant? What sort of...
If we see that the cells would actually... We don't particularly work with any resistant cell lines at the moment, but if you're seeing that you're treating a cell line for a particular period of time, and instead of actually achieving usually what you want, which is cell death, that those cells are actually acquiring a mechanism, then what we'd be doing, in my case in particular, is actually going and looking to see what inside the cell is giving it that advantage, what we call to be an advantage. Is it a gene that is switched on now that it didn't have switched on before, that now lets it grow in comparison to normal cells? You know, it could be anything. So based obviously on our experience and what we are sort of working on, we can go and then sort of evaluate
So
that.
isn't that absolutely amazing, I've got to say? So your job must be rewarding?
Absolutely, yes. I love what I do.
You would need to love what you do with all of that. So I'm just going to let you see those again. Look how many samples.
There is a lot of them, yes.
She's testing.
They're absolutely everywhere.
She's testing everywhere. So
I've expanded to different bays and all.
Anyway, I'm just going to leave it there for another little second.